Alright, so last time we learned how to graph our parent function. So let's start with Mikkel. How do we graph sine?
Add 0 because it says 0.
Alright.
Then it's pi over 2 goes up to 1. Then down to 0 at pi. Then negative 1 is 1 pi over 2. And back to 0.
Awesome. Okay. There you go. That's sine. How do we remember that? When we were going around the unit circle, what were we measuring? The height, right? So the height at 0 is 0, and then at pi halves it was at the highest, and then it went back to 0, then got to the lowest, and there we go. And then it just repeats itself. Good job, Mikkel. All right, so then let's go to Hiram. What about cosine? How is that different than sine?
It starts at 1.
Uh-huh.
It goes down. And then it goes back up.
We went to 0, yeah, it goes down to negative 1,
Yeah.
and then we go back to 1. There's actually this Brian McKnight song, and maybe you've heard it. He talks about how you start back at 1. He goes through a list of reasons why he likes this girl, and then he starts back at 1. Do you know what I'm talking about? I'll play it for you later. But every time I grab cosine and it says start back at 1, I'm like, oh, he's talking about cosine. We'll listen to it later. Okay, so there's a sloppy cosine. Okay, how did we get cosine? What were we measuring here? The lengths, okay? So that unit circle, or not unit circle, the wiki sticks that you did, just remember those. Now, we also talked about two transformations last time. We talked about amplitude. Amplitude was when you times on the outside, it was like the vertical stretch, and then we changed the period when you multiplied by a number on the inside. What we're going to do is continue with amplitude and continue with period change, but we're also going to talk about shifting it up and down and shifting it left and right. And we call those left and right phase changes. That's when you move it left or right. So we're going to do all the transformations here. Last time we only did a couple. Okay, so let's just quick review on this. I'm actually going to have you guys help me. So I want to start with Josh. You're going to do the domain, Micah range, tau. What kind of symmetry do we have here? Brandon, Max. Then we'll go to Kara for the min. End behavior will kind of split up. We need to talk about what is the end behavior. But Adam, I'm going to go to you on that one. Period, amplitude. Okay, so what is a domain? Good job. It's all real numbers. But Micah, what about the range? Good, and we're going to use brackets because we include those. We talked about that last time, but tau, what about symmetry? We didn't talk about that. What are the two types of symmetry that we've been talking about? Do you guys remember there's odd and even? So odd is where you could flip it over 180 degrees and it would land on itself. And even, do you remember how we flipped that one? Even is y-axis. So if I flip this over the y-axis, does it land on itself? No. Let me see if I can do this. But if I go, so I'm going to try this out. I'm going to trace this. And then I'll need to go backwards. Wait for it. Okay, now I'm going to flip it over. Boom, it landed on itself. Did you see that? Technology's so cool. All right. Okay, so what does that mean? What kind of symmetry is it? Odd. Good job. Hey, what's the max, Brandon?
1.
What's the min, Kara? Okay, now Adam, what about end behavior? When we talked about end behavior, that's a number that it's approaching. This one's kind of tricky because what's it approaching? Here's a real question, Adam. Have you seen Mean Girls? No. Okay, never mind. Has anyone here seen Mean Girls? Think of the very last math question Lindsay Lohan answers. Do you remember that? It was talking about limits. And what was the answer? The limit. Come on, Mean Girls people.
I don't have it memorized. The script.
Man. It was the limit does not exist. Do you remember that? Alright. Never mind. I would say go home and watch Mean Girls, but then if your parents were like, what is this you're watching? Mr. Solberg told me to watch it. Then I'd get in trouble at parent-teacher conference. So anyway, think about this thing. What happens? It keeps oscillating. So does it ever approach a number? It just keeps kind of going through this wave. So what we're going to say here is it doesn't ever approach a number. It doesn't have an asymptote. It just keeps going like this. We put DNE for the limit does not exist. Next time you watch Mean Girls, you'll be like, that's what Mr. Solberg was talking about. All right, now, period is the length of a cycle, and what did we say that was last time? One rotation is 2 pi. If you remember, we went around one full circle to make one cycle of sine. Okay? So that was 2 pi. And the amplitude, the distance from the midline to the max, is... So sine looks like a Slytherin snake. That's scary. Anyway, I have a story, but I'll tell you later so we don't run out of time. If you remind me, end of class, remind me to tell you my snake story. Okay, cosine, we kind of talked about this last time. When we filled this in, what did we see? It was the exact same, right? Is the domain all real numbers for cosine? The range, just -1 to 1. Ooh, but what about symmetry? Is this odd? If I flip this over 180, does it land on itself? No, this one is actually what? Even. Should I try to show that? I don't know if this will work out as well. I want to because technology, right? I have this smartboard, so I might as well use it. So I'm going to go, and now I'm going to flip it left, right. So let's go to the flip. Left, right. Oh, hey, come on. Flip, left, right. And it flipped, and did it land on itself? Yes, what does that mean? You couldn't tell that it flipped because it looks just so much like it did before, but it did. That means that it's even. Hey, come on, Penny. Okay, what is a max? Min is -1. What about end behavior? What are we going to put there, guys? DNE, the limit does not exist. When you go into calculus, you'll see that a lot. Period is still 2 pi, and the amplitude is 1. All right, do you have any questions? This is our basic parent function information. All right. And cosine, it looks like a bunch of cups. Do you get it? Cosine cups, sine is snakes. All right. Now, guys, when we write out all possible transformations, it's going to look like this. You've got A on the outside. On the inside, you're timesing by B, but adding C, and you're also adding D. So there's a lot of different ways we can transform this. So let's go through all the different letters and what they do. Let's start off by talking about A. We said A is the amplitude. What is the amplitude a lot like with our other parent functions? What is it doing to it? Stretching it which way? Good job. This is like a vertical stretch. But usually with our parent functions, we saw this just stretching up. This will also stretch down. Okay? So let's go through and see an example of that. So if I'm just graphing plain old cosine, where do we start at? At its maximum, which in this case, I'm going to do A in purple. Okay, so I'm going to say here's 1 and here's -1. So I start, and this is how I like to do my graphs. I do a starting point and then I do an ending point. So where does cosine go through one full cycle? How long does it take? 2 pi, so I'll put an ending dot here. That means halfway through it's going to be at -1 at its minimum, and then the quarter points are at the x-intercepts. So when I graph one cycle of cosine, it looks like that. That's just plain old cosine. Now, what happens if cosine by 1/2. How's that going to be different? Peyton, what do you think? Awesome. So now it's going to still start at its max, but now it's only 1/2, and the minimum is only negative 1/2. So in this case, it wasn't much of a stretch, it was more of a shrink, right? So this is 1/2 cosine of x. All right. And granted, that will just keep going and going and going. We're just doing one cycle here. But Michael, on C, we've got a negative 3. So first off, what is that 3 going to do?
They're make the taller, negative number taller.
Yeah.
That's
Awesome. So the stretching it out. But what do you think that negative will do? So now instead of starting at your max, what are we going to start at? The minimum, which is what? There we go. So I'm going to come down here to negative 3. And then I'm also going to put a point at 1, 2, positive 3. So this is going to start at negative 3. And that means it's going to end at negative 3. So I like to do a start and a stop point, so I make sure it's spread out the way it needs to, okay? So that means halfway through it's going to be at its maximum point. And it's not being stretched horizontally, so it's going to still have those same x-intercepts, okay? So if I were to graph this, it'll look something like that. That's negative 3 cosine of x. How could you check your work here? Thank you. Desmos, you just graph it. If you use your graphing calculator, make sure you're in radians, because we're measuring this in terms of radians. You could do it in degrees, but then you have to go all the way out to 360, okay? So that's a little complicated. Do you have any questions on amplitude? It's what we did last time, so hopefully that's just a good refresher in your brain. Okay? Well, so then let's go now and let's talk about the effect that B has. Timesing on the inside, this is what we called last time a horizontal stretch. Or when we did our parent function project, we talked about horizontal stretches. And what was tricky about horizontal stretches? What did you have to multiply by? The reciprocal. And we're going to see that same thing here, okay? Our period is equal to 2 pi. However, if you're timesing by b on the inside, what that's going to do is it's not going to times 2 pi by b, it's actually going to times it by 1 over b, which is the reciprocal, right? So we're seeing that same idea here, is that whatever you times by affects the horizontal stretch by the reciprocal, okay? So let's go through a couple examples of this. All right, let's do plain old sine. And on this one, we're going to do a couple of these just for us to see this here. And what I'm going to do is I'm going to make it look like this. Help me out here, guys. I want you to do this. So we're going to make each one of these worth pi. So that's 1 pi, 2 pi, 3 pi, 4 pi, and extend it 2 more with me. So that's 5 pi and 6 pi. And that means we're going to extend it this negative way as well. All right, so let's do plain old sine. And we're not going to make this too complicated here, okay? So we're going to put, here's 1, here's negative 1. All right, Angelina, where does sine start at? Yep. And then how long does it take it to go through a cycle? Or, well, period. What is the period? The length of one cycle is a period, so we could say it either way there. 2 pi, alright. So that means halfway it's right here, and then it goes up, and then it goes down. So it's just going to look like that. Now I'm going to keep adding in this right here. So by the time we get to 6 pi, we've gone through 3 cycles. Up, down, back, up, down, back, up, down, back. And sometimes my graphs go a little more down, but you get the idea, right? And if I wanted to go backwards, we could do that here as well. Okay, now I'm only drawing that just so we can have an idea of what it looks like compared to the original. Okay, let's look at B for a second. Josh, tell me one thing that's going on B. We'll start with Josh Lim and then we'll come to Joshua. We got 3 things going on there, so tell me one of those, Josh Lim. Good, so what does that negative do? Say that again, okay. So that 2 is going to double the heights, right? So our max is now at 2, our min is at negative 2. What does the negative do? We kind of saw back on this one with the blue one. Where we had that negative. Say it again. We started at our minimum instead of at our maximum, so it kind of just flipped it over, right? So that negative is just going to reflect it over the y-axis, or we could just say it's going to flip it, okay? Now, Josh, what about that period? What is being multiplied by the inside here? 1/3. Good, so what's the reciprocal of 1/3? There you go. So what we're going to do is normally we do this. We do period is 2 pi over b. But in this case, b is 1/3. So when I do keep, change, flip here, I'm going to flip that 1/3 over, and it's going to become a 3, which is just going to be 2 pi times 3, which is 6 pi. What that means, guys, is how long does this take it to go through one cycle? Is that shorter or longer than normal? Because normally it's done in 6 pi, right? Or in 2 pi. So that means it takes 3 times as long to complete one cycle. Okay? So this one we're going to have a couple changes. So first what I'm going to do is I'm going to show here's 1, here's 2, here's 3. Down here, here's negative 1, here's negative 2, here's negative 3. And I'm also going to kind of help myself out here by doing something real quick. I'm just going to draw this line in here at negative 3-ish. So I have an idea of where I'm drawing it, so it's a little better. Okay. Now, since it's been flipped over, oh, we're only at 2. Why did I go to 3? That's the next one, okay. Sorry, guys. Okay, so we're going to have stretch up to 2, stretch down to negative 2, except it's been flipped. So what does that tell us? Instead of starting at 0 and going up, what are we going to do? Start at 0 and go down, okay? Now, this can be tricky because there's 3 things going at once, so let's be smart about it. So sine starts at 0. How long does it take this sine curve to go through one cycle? So I'm putting my end point at 6 pi. Now, halfway between 0 and 6 pi is 3 pi, because that's the halfway spot is also at 0, because it's going to go up, then it goes down, and then we're done. What's halfway between 0 and 3 pi? 1.5. So I'm going to come here to 1.5, but we're not going to go up to our max. What are we going to do? Go to the minimum because it was negative, which will flip it. Then, halfway between 3 pi and 6 pi, I'm going to go up to the maximum, and that's where we're going to see this point here. So it's going to look like this. It's going to go down to negative 2, up to positive 2, and then it finishes one cycle at 6 pi. Now, going the other way, we're going to do the same thing. So it finishes another cycle here at negative 6 pi. So at negative 3 pi, it's halfway done. Between 0 and negative 3 pi, it's going to be at its maximum point of 2. And halfway between negative 6 pi and negative 3 pi, we're going to be down at our minimum point of negative 2. So it should just look like the one we did before. I like that. Okay, I want you, after you've graphed that, to pause and turn to your neighbor, and I want you to compare the green sine graph to this transformed one. How is a transformed one different, and why is it different? What made it different? Go. All right, let's pause real quick. I want to hear Brinley and Charlie, what were you saying?
I said the difference is the vertical and straight horizontally.
Yeah, we stretched it vertically and horizontally. And then what else did we do?
And then flipped it.
We also flipped it, so it has 3 changes, okay? So then, guys, go back to your neighbor. What's going to happen on C? With your neighbor, why don't you just guess at what the transformations are going to be real quick? Hiram, what are you thinking? On C, what's going to happen? Stretched and stretched? Yeah. How is negative going to be different on this one? What? I said, how is the negative going to be different on this one? If it's on the outside, it's over the x. What about this one?
Oh, I meant
What was that?
I meant the y-axis
Yeah.
just came out of the x-axis.
Okay, yeah. All right, let's go to Brandon and Kara. What did you guys decide? What's one transformation that's going to be different on this one?
Instead of being called flipped vertically, it's going to be flipped horizontally.
So it's going to be flipped over the y-axis. All right, cool. Ofa and Mikkel, what's another thing? Nice job. So this will go up to 3, down to negative 3. Okay? And then lastly, guys, let's do this one together. For the period, we're going to do, if you look back at our notes here, you do 2 pi over the absolute value of b. So the negative isn't going to make a change, right? We're just going to do 2 pi over 2, which is what? Now, what does that tell us? It completes one cycle in pi, which is twice as fast. So where I see these green ones and it's like done at 2 pi, ours is going to be done right here. Now, this might take some precise drawing on a sloppy graph, but let's try this together and then we'll see if we can throw this in on Desmos to make it look better, okay? So sine, where does sine start? Starts at 0. Okay, now what's going to happen on this one is we're going to need to kind of flip this, okay? So normally, if you look at our green graph here, normally it goes like this. Goes up and then down. But if we flip it over the y-axis, what's going to happen? Is it going to go up first or down? It's going to go down. Since this was odd, did flipping it over the y or flipping it over x, is it basically the same thing? Like think of x cubed, right? If I flip it over the x, what does it look like? But what if I flip it over the y? What does it look like? These change and it's the same thing, right? So it's going to have the same effect as flipping it over the x. So we're going to go down first. Now, what are we going to go down to? What are we going to reach? Negative 3. And how long until we complete one cycle?